Let's look at final exam, question number 41 in Trigonometry Demystified, 2nd edition. Please refer to page 375. We're dealing with MPC, that is called mathematician's polar coordinates, where we have a direction angle theta, which goes counterclockwise from due east, that is straight to the right, 0, pi over 2 radians, pi radians, 3 pi over 2 radians. That's the direction angle. And we also have a radius coordinate, which is simply the distance of a point from the origin being right there in the center. Now we have an equation here that's described by this question. The radius equals 3 theta over 4. The radius equals 3 times the direction angle over 4, which we might also write as 3/4 times the angle. So the radius varies in direct proportion to the direction angle. Well, when theta equals 0, we can see easily enough that the radius is going to be 0. So the origin is part of this graph. When theta becomes pi over 2, the radius becomes 3 pi over 8. Anyway, the radius is going to increase in direct proportion to the direction angle, as you'll be able to see. And if you keep going past here, to make it redundant, this would be 5 pi over 2. And so on and so on. You're going to get a spiral like that. But you will also get the mirror image of this spiral, because if you let theta become negative, that is, you go clockwise, you're going to get the negative of the radius. So what you're going to get, for example, if theta equals pi, you get 3 pi over 4 for the radius. If theta equals minus pi, then you get minus 3 pi over 4 for the radius. So, in effect, you're going to get another spiral that goes out in the opposite sense. So the correct answer to this question is E. You're going to get a pair of spirals when you graph this equation.